Hi, my name is Kelland and I'd like to talk about gyroscopes. Gyroscopes have been of interest to scientists for more than 100 years. The reason for this is that gyroscopes seem to defy gravity. Now what I've done is set up a series of demonstrations to explain my theory and show you how gyroscopes achieve lift. This will also allow me to explain several other attributes of these instruments. Now, I have here in my hands a little toy gyroscope, and by inserting this plastic doohickey here into the slot provided and pulling on it, I can set the wheel inside spinning at a very rapid rate. Now I'm going to set this gyroscope down on the table next to me on a pedestal where we can observe its characteristics. Now notice that when this wheel starts tilting over towards the table, it maintains itself, it doesn't fall off. And the reason for that is the more this wheel is oriented towards the surface of the earth, the greater the lift. So now the momentum is greatly decreased, but it still doesn't fall off. Notice, even when it's vertical to the surface of the earth, it maintains itself erect. Even in this position here, when it's completely out of balance. Now I'd like to talk about the other property of these gyroscopes. This property is referred to as precession. Okay, as it loses momentum, it begins to rotate around this pivot point here as it falls off. The reason for that, the more this is tilted towards the center of the earth, the faster the rotation. Look how fast that keeps going, even though it's running out of momentum. What we saw in that last demonstration was that the wheel rotates around its pivot point, around the pedestal, faster when it's oriented more towards the center of the earth. In addition, we found that lift actually increases as it's oriented more towards the center of the earth. This allowed it to remain suspended like this, even though it lost most of its angular momentum. Now, what is there at the center of the earth that might be causing this? Well, the obvious answer is the gravitational force field. At the center of the earth, we find the strongest gravitational force field because that's where the greatest mass is. So it seems as if gravity is somehow interacting with this wheel to convert part of the spin angular momentum into lift and precession. Now to sort this all out, I have in back of me a different type of gyroscope, and let's take a look at that. This gyroscope is made out of an ordinary bicycle tire. It's attached to the ceiling with this rope, and it's attached to only one side of the axle. So for this reason, when I hold it like this and let it go, it falls down. Of course, it falls down because of gravity. However, if we set it spinning like that, it remains erect. In addition, notice how it is spinning around and around. This is the precession that we noted earlier. Now this is all rather strange if you think about it, because the tire going down on this side, the momentum of the tire, is exactly equal to the momentum of the tire going up on the other side, and these should counterbalance each other and there should be no net lift. But obviously we do get lift. At the same time, the momentum of the tire going in this direction is exactly equal to the momentum of the tire going in that direction, and we should get no net precession. It seems then that something must be interacting with this tire to cause this effect. Now this whole thing reminds me of an airplane propeller. No matter how much the engine roars, no matter how much momentum is built up in that airplane propeller, it cannot cause the plane to taxi down the runway unless it interacts with another factor. And we know in this case the factor is air. Air is being pushed to the rear by the propeller, and this causes a forward thrust and the airplane taxis down the runway. So by this means, the spin angular momentum of that airplane propeller is converted into linear momentum. And this is exactly what we'd expect for this gyroscope as well. There's no way to convert spin angular momentum into lift and precession unless this wheel is interacting with some other factor. Now I'd like to show you something rather dramatic. To do that, I'll need to put these gloves on. Now I'm going to set the wheel spinning and grab it up here at the top. Look at that. We get lift and we get precession. Now what's going on here? Now normally the center of the spin angular momentum is here at the axle, but when I grabbed it up here, the center of this momentum shifts to my hand. And now the whole wheel is attempting to rotate around my hand like that. And notice when it does so, the axle is going forward and we're getting lift. Let's try that again. If I grab it way over here, we get lift. Or way over here, we get lift and precession. In fact, if I grab it way over here, we get even more lift and precession. Like that. Now it is true, if I were to grab it down here at the bottom, it would attempt to go down. So this gives us the opposite effect of grabbing it up here at the top. However, if we could explain how we get greater resistance up here at the top versus the bottom, we'd go a long way to explaining how the spin angular momentum is converted into lift and precession. Now this brings me to my elastic string theory. It is my theory that all the forces of nature are created by virtual elastic strings. This includes electricity, magnetism, nuclear forces, and the gravitational force of attraction. Now, all of these strings are composed of matter and have mass. Now, this is actually dictated if we live in a three-dimensional world. Also, I've been able to shoot spinning ping pong balls through a magnetic field and show that they actually curve more when the field is on than when the field is off. This shows us that the fields have physical properties, which means they are composed of matter. Now, there are a couple of other important properties of matter that I would like to discuss. One of these is perfect elasticity. And I'll get this little bottle. Now when I put the cap on this bottle like that, the air molecules trapped inside of this bottle will continue to move about essentially forever. The reason for that is when they strike each other, they move away with the same velocity and the same momentum that they had before the collision. Physicists speak of this as perfect elasticity. Now we know that all molecules and atoms share elastic properties because they're all made from the same small building blocks. Another important property of matter is that it cannot be destroyed. Well, to me, this means that if it can't be destroyed, it must have perfect cohesion. I believe that perfect elasticity and perfect cohesion stem from the same property of matter. This explains how a graviton that causes the gravitational force of attraction can be ejected across the Milky Way galaxy and onto the Andromeda galaxy and stay intact. It does so because it has perfect cohesion, and it retracts back to the Earth, perhaps causes a force of attraction because it has perfect elasticity. Now there must be a vast number of these strings emanating from Earth to account for the energy relationships between the Earth and the Sun, for example. In fact, there must be something like 10 to the 56th power in every square centimeter to account for the gravitational force of attraction between these two large bodies. Now, we can't see these strings in space because they're composed of matter, and matter takes up very, very little space. For example, we can't see the air molecules in space. Also, we should reflect on this, that the Earth itself, if you removed all the empty space, it would contract into a very small ball. So matter is rather weird, we might say. It occupies very little space. Now, we can't feel these elastic strings in space either because they're extended over a great distance and they have perfect elasticity. Also, think of this. When you move your hand like that, all of these strings here have been instantly regenerated, while the strings over here have disappeared. That's because they have virtual properties. Now let's turn our attention to how these strings might interact with the gyroscope. So we can imagine then that there's just a vast number of strings emanating from Earth, and when these gravitons penetrate the tire, they bind to it, and when they retract, they pull this tire back down towards the Earth. At the same time, the tire itself is creating gravitons, and when they enter the Earth, they become bound to the Earth, and when they retract, they also cause a force of attraction between the tire and the Earth. Now, however, when the tire is spinning like this, the strings will tend to wrap up like this. And if this tire spins twice in 1 second, there'll be 2 complete wraps around the tire. Now you may ask, what causes these strings to remain in place? Why don't they just slough off when they retract? Well, the reason for that is that they are bound in place by other gravitons arriving here from other sources. For example, the whole Milky Way galaxy is feeding into this area. In fact, there's something like 10 to the 46th power in every square centimeter arriving here from the Milky Way galaxy. In addition, we have our sun and moon and all the planets furnishing gravitons into this area. It's just that the Earth, that's very close to us, is creating more gravitons per square centimeter than from any other source. Now, as these strings become wrapped around here, then they're only feeding off on one side like that. This means the strings are pulling down from the top up here, isn't it? In fact, I would put some wax candles underneath a nylon thread and pulled on the thread down below, and I was able to show that the wax candles are only notched along the upper portion of it, none of it down here below. So this means that the gravitons retracting back to Earth in this direction are pulling from the top preferentially. And this then furnishes the resistance needed to create lift and to create precession. So once again, because there's greater resistance up here at the top than there is at the bottom, then the wheel is going to try to rotate around the top, which is going to cause the axle to go forward, which is precession, and it's going to cause the tire to lift. Now what we have discovered is that elastic string theory is able to explain why a gyroscope achieves lift and why it achieves precession. It also shows us why there's greater lift and greater precession when the wheel is oriented towards the center of the Earth. Now, if you'd like to learn more about my theory, I invite you to go out to my website, and there you'll find a PDF file of my book that you can download. This book describes elastic string theory in detail. Also, you'll discover that I have been able to analyze and explain many other conundrums of science that puzzle scientists for hundreds, if not thousands of years. And I invite you to go out there and discover that for yourself. Thank you very much for listening, and thank you very much for watching, and you have a good day.